Uh, Good morning. We are going to be concentrating on algebra, guided by the paper which was written in June 2025 from the Eastern Cape Department of Education. So please don't forget to subscribe. So we are going to go to question 1. Question 1.1, you are given x squared. So question 1.1.1, you are given x squared plus 2x plus 1 equal to 0. So it means you can use, it's 2 marks. You can use the quadratic formula. So copy your quadratic formula from the formula sheet. So it means your x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. But you have to take note the values of a, b, and c. A is the coefficient of x squared, which is 1. Then b is the coefficient of x, which is 2. Then c is the constant, which is 1. So substitute those values in the formula. So we are going to be having minus our b is 2 plus or minus the square root of b squared, which is 2 squared minus 4a, which is 1, c, which is 1, all over 2a, which is 1. Conclusively, our x equal to, or our x equal to, so we are now going to punch from our calculator. Trust your calculator. So we are going to have our calculator. So punching on the calculator, we are going to have minus b is 2 minus the square root of b, which is 2 squared minus 4a is 1, c is 1, all over 2a is 1. We are getting a negative 1. Then go and change our sign there so that we put a positive here. We are getting a negative 1. So conclusively, we are going to have our x equal to a negative 1, or our x equal to a negative 1. Alternatively, we can use factorization. X squared plus 2x plus 1 equal to 0. Then we are going to be left with factorize that. We are going to have x plus 1, x plus 1 being equated to 0. How did we factorize that? Product, we take the multiply the constant and that term, we are getting 1. X squared. Sum, we are taking the middle term, which is equal to 2x. Then factors, we are going to look for two numbers. If we multiply them, we are going to get a 1. So we can talk of 1 and 1, or negative 1 and negative 1. But when we add those two numbers, we must get 2. So these are the two numbers. So it means here it's going to be 1x plus 1x. So where there is the sum there, the middle term we substitute by the factors. So we end up having x squared plus x plus x plus 1 equal to 0. Then we factorize by grouping. So the first two terms common factor is x. Then in bracket we are left with x plus 1. Then in the second one, the common factor is positive 1. In bracket we are left with x plus 1 being equated to 0. Then the repeated bracket, you write it once. Here it's x plus 1. X plus 1. Then this term, we take that one plus 1 is equal to 0. That's how we arrived here. Then from there, we can equate each bracket to 0. X plus 1 equal to 0, or x plus 1 equal to 0. Therefore, our x will be equal to a negative 1, or our x is equal to a negative 1. That is after transposing this one here and transposing that one here, which are the answers that we obtained here. We can also use the completing the square method, but we'll talk about it later. Then let's go to the question. Next question. We are given on question 1.1.2, we are given x, then we are having 5x minus 3 being equated to 1. So the first step is to standardize your equation. So it means we have to remove the brackets. So when you multiply this here, we are going to get 5x squared. Then we multiply this here. We are going to have minus 3x, then transpose this one to the other side there. Take note, this one is not multiplying, but it's actually transposing. When it comes there, it was positive, it becomes negative. So negative 1 equal to 0. Then from there, we have to take note A, using the quadratic formula. A is the coefficient of x squared. B is the coefficient of x, and C is the constant. So take these, go and substitute them in the formula. If we are to substitute these, we are going to be left with, copy the correct quadratic formula. Here is the quadratic formula. So use the quadratic formula. So it means our x gonna be equal to minus our b, it's a negative 3, plus or minus the square root of b, which is negative 3 squared, minus 4, our a, which is 5, then our c, which is negative 1, all over 2, our a, which is 5. Then we go to the calculator. So your x, and take note, pay attention to details. The question is strictly said correct to 2 decimal places. Correct to 2 decimal places. So we are going to pay attention. So x there will be equal to, or our x will be equal to, we go to our calculator. So it's gonna be square root of minus b. So it's minus our b, it's minus 3 plus the square root of, it's minus 3 b squared minus 4. Our a is 5. Our c is minus 1 all over 2a is 2. Our a is 5. So we are going to get the answer saying to 2 decimal places. So it's gonna be 0.84 because this third digit after the comma is greater than 4. So 0.84. Then to get the other one, we are going to put minus there. And changing negative 0.24. So our answers are negative 0.24 and 0.84 as obtained on the calculator. Alternatively, we can use completing this square. So let's take care here. If we are using completing the square, it therefore means that we are going to have, first step, we are supposed to make sure that we standardize our equation. After standardizing our equation, let's divide throughout by our a. So our standard equation, that is O 1.1.2. So it's gonna be 5x squared minus 3x minus 1 equal to 0. So we are going to divide throughout by 5, because we always have to make sure that the coefficient of x squared is unit. So in other words, we divide here by 5, divide by 5, divide by 5, divide by 5. So we are going to be left with x squared minus 3 over 5x minus 1 over 5 equal to 0. Then we leave only the terms with x on the other side. So we are going to have x squared minus 3 over 5x equal to 1 over 5. Then both sides we are going to add half the coefficient of x, so squared. So it's gonna be x squared minus 3 over 5x. Then here we are going to say add half the coefficient. So half, we check, we are saying half the coefficient. We said we are going to add both sides half the coefficient of 3 over 5, this squared. So if we simplify that, it means we are going to add here. So that one is going to be negative 3 over 6 squared being equal to 1 over 5 plus negative 3 over, sorry, it's 10. 2 times that is 10, not 6 there. The denominator there is supposed to be 10. So negative 3 over 10 squared. Then on the left-hand side, we are going to be left with x minus 3 over 10 squared must be equal to, simplify, because this side is now a perfect square. Here we completed the square. This is now a perfect square. This one. So that's how it reduced to that. So that must be equal to, we go to the calculator and simplify that. So if we go on the calculator, we are going to be left with we are to go on the calculator. So it means we are going to be left with 1 over 5, 1 over 5 plus, so it's a negative 3 over 10 squared. That is going to give 29 over 100. That is going to give 29 over 100. So this is going to give us a 29 over 100. Now you find the square root both sides. But this other side, we are going to put a plus or minus. So we are left with now two equations, so the square root here, it's gonna be x, because the 2 power and the square root are cancelled. So we are going to be left with x minus 3 over 10 being equated to root 29 over root 100, which is 10, or x minus 3 over 10 must be equal to a negative root 29 over 10. Then from there, we take this to the other side. So our x is equal to 3, this root 29 over 10. Take this one to the other side. If we are to take this to the other side, to change the sign to positive. So plus 3 over 10, or the x is equal to negative root 29 over 10. Then taking this to the other side, it becomes positive. So it's gonna be plus, what is happening? Okay, plus 3 over 10. And simplifying this on the calculator, it therefore follows that x is equal to, we just have to use our calculator. So it will mean that we are going to have root 29 over 10 plus 3 over 10 plus 3 over 10, which is going to give 0.84 or we are going to have negative root 29 there plus 3 root 10, which is going to end up giving us negative 0.24. So our answers here, we are having either 0.84 or a negative 0.24, which are exactly the answers that we got using the quadratic formula. Then we go to the next question, which is an inequality. Let's create space for the inequality. So we are now on question 1.1.3. 1.1.3. So they are saying 2x squared, 2x plus 3 is greater than x squared. So step number 1, we have to standardize the inequality. So we are going to transpose the x squared to this side. If we are to take the x squared to that side, we are going to be left with x. We are going to be left with a negative x squared, a positive 2x, a positive 3 are greater than 0. Then the next step, let us negate the inequality. So if we divide or multiply an inequality by a negative, always take note that the inequality sign changes. So what it means is that we are going to be having negative x squared plus 2x plus 3. Then we divide throughout by a negative 1. Our inequality sign from there changes. So we are left with x squared plus, it's now minus 2x minus 3. It's less than 0. I always recommend that your A, make it positive. But always remember, if you divide or multiply by a negative, when dealing with inequalities, the inequality sign changes. So once you have this, you have to determine the critical values. So in determining the critical values, so here we have our critical values. The moment we are talking of critical values, we substitute the inequality sign by an equal sign. The moment we are talking of critical values, therefore, here we can use factorization. If we are to use factorization, this becomes x minus 3, x plus 1 being equated to 0. So x minus 3 equal to 0, or x minus plus 1 equal to 0. So it means our critical values, we have 3, and the other critical value is negative 1. Once we have the critical values, always make sure that once your inequality has been put, once your A here has been written in standard form and your A is positive, if your inequality is less than, we can just come and write our solution as the middle part, which we write from the smaller to the bigger. So it means the solution here, it becomes minus 1 less than x less than 3. But we have to take note that on this standard form, if our inequality was greater than here, if our inequality in this case was greater than, it means we're going to have two solutions, one which says x is less than the lower limit, or which says x is greater than the upper, that critical value. So here we are dealing with this one, so we have this, but this only works if the coefficient of x squared is positive. Now, so this becomes our solution here. That becomes our solution here. But you'd realize that after getting critical values, after getting all the steps that you are doing be the same, after getting critical values, depending on the method that you understand better, you can use the graphical method. So using the graphical method, we read from the standard there where we got our standard. So if we are to check, this is where we get our standard, and our A is positive. We know if A is positive here, if A is positive, we are taking from here, our graph, it's like this. But if A is negative, our graph will be facing down. So using that, it therefore means from here, after getting the critical values here, we were going to sketch the graph. So we only need the horizontal axis. Then this is our sketch with our limits at -1 and 3. Then we go here, we say less than 0. If we are saying less than, we want where the graph is below the horizontal axis. So our graph is below, within this range. So it therefore means we take note, we used this as our standardized format there. So how do we write this inequality? Is between -1 and 3. So our solution set will be written as from -1 less than x less than 3. Take note, our inequality was not accommodating or equal to. Still, we also have to take note, it was possible that one would use the graphical way, but we use the graphical way from this format, from this part before with the negative. You have to know that this is our standard, but it's negative. And we know when our A is negative, our graph will be like this. So if we were to use this, and therefore means that we were going to have, take note, from here, you use even the quadratic formula, you're still going to get the same critical values which we obtained here, our critical values. Then from there, if we were to take from here, it means your graph was gonna look like this. This is our x, but because our A is negative, our graph was gonna be like this. Then from there, here it's -1, and here it's +3. Then we go and check here from the standard form. It's saying this is greater than 0. So when we are saying greater than 0, we want the part of the graph which is above the x-axis, because we said greater than 0, meaning to say we're going to take this part of the graph which is above. So it therefore means our solution still is between -1 and 3. So our solution was going to be -1 less than x less than 3. Then lastly, it was possible that you can use, apart from using this just inspection or using the graph, you can use the table. Take note, once you get the critical values here, we just go. Once you get the critical values, we go to our table. And always you have to know that we are having -1. So we want values which are less than negative. The values which are less than -1. So they are represented by x is less than -1. Then we want the values which are between -1 and 3. It could be -1 less than x less than 3. Then lastly, we want the values which are greater than 3. It means our 3 is less than x there, or our x is greater than 3. Then when we are having this now, you just have to come in your term here, you find the region that you want. You can decide to say, I want this region. So if you choose this region, you are going to check a number which is less than -1. For instance, -2. You come and substitute the -2 in the standard form, this one. So here, take note, we are using this one which is having positive, where a is positive. So we are using the standard form here. So come and substitute a number less than -1. We can substitute -2. So go to your calculator. Go to your calculator. Substitute the -2. Substitute the -2. So we're going to get a -2 squared minus 2 multiplied by a -2 minus 3. If you check, we are getting 5. We are getting 5, which is a positive. We are getting 5. You can check. We can substitute. We are not much interested in the actual value. We are interested in the sign of a number. You are interested in the sign of a number. You can check another number which is less than -3. We can substitute maybe by a -5. If we put -5 there and come and put a -5 again, you see we are going to get a number. It's positive. So from what you are seeing, we are getting a positive. So we got here a positive. Then always know that the pattern will be interchanging once you arrange your regions in ascending order. Here it will be negative, here it will be positive. You can do it by testing a number which is between -1 and 3. We can substitute 0. If we put 0 here, 0 there is 0 minus 3. The answer is negative. Then once we have done, you are now having a table like that. You go back to the inequality where it's standardized. Where is it saying this is less than 0? What is the sign of a number which is less than 0? We know it's negative. And where are we getting negative? Here is our negative. So we can therefore come and write our solution. So here our solution, we are going to take the part which is having a negative. So the part which is having a negative is this one. So our final answer is -1 less than x less than 3. But take note, apart from using this notation to write your inequality, you can use this inequality, which is our answer, can be written as x is an element from -1 up to 3. And we are not going to use square brackets. Why? Because our inequality is not accommodating or equal to. Then we go to the next question. We go to the next question, which is question 1.1.4. Question 1.1.4. 1.1.4. You are given that 7x minus 12 root that is equal to, not is equal to, it's saying minus x is equal to 0. So first step, always leave the surds on their own. So it's going to be equal to 7x minus 12 equal to, it means we are going to transpose the x. It goes to the other side. So it's going to be equal to, when it goes there, it becomes positive. It becomes x. Then we want to take root of this root sign. We are going to square both sides. Here we are going to be left with 7x minus 12 equal to x squared. From here we are now going to standardize. We take everything to that side. So our 0 is equal to x squared. Take this one to that side. If you take this to that side, take this one again to that side, they are going to change their signs. So it's gonna be minus 7x. It's gonna be minus 7x plus 12. Then here you are now having a quadratic equation. So with the quadratic equation, as always, you can use the quadratic formula, which I recommend in most cases, or you can use factorization. If we were to use factorization here, we're going to be left with x minus 3, x minus 4. Then you solve your x minus 3 equal to 0, or the x minus 4 equal to 0. Solve this, x is equal to 3, or x is equal to 4. Or you are going to use the quadratic formula. Let us check the quadratic formula. Just want to check the quadratic formula. So it means if we were to use the quadratic formula, you are going to start from here, copy the quadratic formula, x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Here, what's the value of a? A is equal to the coefficient of x, which is 1. B is equal to the, A is coefficient of x squared, B the coefficient of x, which is minus 7. Then C is equal to the constant, which is 12. Substituting those in the quadratic formula, it's going to give us minus B is minus 7 plus or minus the square root of B squared, which is minus 7 squared minus 4, our A, our C, all over 2, our A. Then we go to our calculator. When you go to our calculator, what are we going to get? So it's going to be equal to minus minus 7. It's minus 7 plus the square root of minus 7 squared minus 4a, which is 1, c, which is 12, all over 2a, which is 1. We are getting 4. Oh, we are going to put minus there so that we get 3. So it means our x is equal to 3, or our x is equal to 4, which are the answers that we get here. But always bear in mind, whenever we are solving equations with surds, it is very important to test the solutions that you get. What is it that we mean when we are saying we are testing? Substitute the values that you get. Yeah, so it means we are going to check our 3. Let's test our 3. So it means when x is equal to 3, when x equal to 3, substitute 3. We are going to substitute 7, 3, minus 12, then minus 3 equal to 0. We also have to test when x is equal to 4, meaning to say we substitute 4, so it's going to be 7 times 4 minus 12 minus 4 is equal to 0. So let's check using our calculator. So we are going to substitute the square root of 7 times 3 minus 12 minus 3. It's giving us 0. Let's check when we put 4. It's giving us 0. So since our left-hand side here is equal to our right-hand side for both solutions, if you check here, left-hand side has been equal to right-hand side, and here, again, left-hand side has been equal to right-hand side. We can therefore conclude that both answers are solutions. X is equal to 3 or x is equal to 4. But if there is one which gives a left-hand side which is not equal to right-hand side, it therefore means that won't be a solution. So in this case, both answers were solutions. Then we go to the next question, 1.1.5. It says 1 over 6 to the power 3x plus 2 multiplied by 206 to the power 3x is equal to 1 over 216. So to solve this equation, they want you to solve for x. Express everything. As we can see, all these things can be expressed in terms of as exponents with 6 as base. This 1 over 6 can be written as 6 to the power a negative 1, then to the power 3x plus 2. Here we are applying the laws. The law that we applied here, it says 1 over x. If we want to express this in exponential form, if we check this x here was having a power 1, if we want to make it a numerator, that x, our power changes sign, so it becomes x to the power a negative 1. That's the rule we applied here. Then we are going to go to the next one. It's saying multiplied by 216 there can be written as 216 can be written as 6 to the power 3. Then that one is going to be saying to the power 3x, which is equal to 1 over 216 can be written as 6 to the power 3. Then we simplify this. When you simplify, we are going to be left with here. We are going to apply a rule which says that a to the power b to the power c will be equal to a to the power bc. We multiply the powers. So it means here we are going to be left with the 6 to the power minus 1, which is multiplied by 3x plus 2 multiplied by 6 to the power 3 times 3x, it becomes 9x. We being equal to this rule, we are going to apply the rule which were applied earlier on, the first rule that we applied, the one marked in red. So this becomes 6 to the power a negative 3. Then here, let's simplify. To simplify the left-hand side, we are going to apply the rule about additions. We know that x to the power m multiplied by x to the power n is equal to x to the power m plus n. If the bases are the same, we add the powers. So it therefore means this left-hand side becomes 6. Then simplifying the power, there is minus 3x minus 2. Then taking this from this row is going to be plus 9x. This must be equal to 6 to the power a negative 3. But since now our bases here are the same, we can equate the powers. So it means that this one, let's simplify this one and this one are like terms minus 3x plus 9x. It's going to give us positive 6x minus 2. That's the power. Must be equal to the power there. The power there is minus 3. Then transpose this to the other side. It changes sign. It will mean that 6x is equal to minus 3 plus 2. Therefore, 6x is equal to negative 1. Divide both sides by 6. So the x is equal to negative 1 over 6 becomes the solution. Our x is given by negative 1 over 6. Our x is negative 1 over 6. Then we go to the next question, which is 1.2. Let's go to 1.2. So here we can take off this. Then we go to 1.2. 1.2. We are given x plus y equal to 3. This becomes our equation 1. We are also given that x squared plus 2y squared equal to 18. This becomes equation number 2, but you have to make sure that one of the equations, you have to, using one of these equations, which is the simpler one, make one variable the subject of the formula. So using equation 1, we can make x subject of the formula. So if we are to make x subject of the formula, it means we are going to transpose that part with I, with y to the other side. So that becomes 3 minus y. Then this becomes our equation 3. Then we have to substitute that equation 3 in the equation which we did not use. Meaning to say wherever there is x, we are now going to substitute 3 minus y. So it becomes 3 minus y squared, where there is x, plus 2y squared equal to 18. Simplify here. So it becomes 9 minus 6y plus y squared plus 2y squared equal to 18. How did we get this? It simply means that where there is 3 minus y squared there, this was 3 minus y multiplied by 3 minus y. This and this is going to give us a 9. Then this and this is going to give us a negative 3y. This and this, a negative 3y. Then here, a negative is positive y squared. But these are like terms. That's how we got negative 6y. Then from there, we can now simplify, combine. Here, these are like terms. We get 3y squared. Then we have minus 6y. Then we are having plus 9. Transpose the 18. We are going to get 0. So our y, 3y squared minus 6y, here minus 9 is equal to 0. We can simplify this. We are going to get y squared. If we divide throughout by 3, if we are to divide throughout by 3, it means we are going to get y squared minus 2y minus 3 being equal to 0. Then to solve that, let's create space here. To solve that, for y means we are going to factorize. We'll end up having y minus 3 y plus 1 equal to 0. So y minus 3 equal to 0, or y plus 1 equal to 0. Therefore, our y is equal to 3, or our y is equal to negative 1. But take note, when we have arrived here, take note, when we had arrived here, we can apply the quadratic formula to solve for y. So it means our x, take note, we are solving for y, so it's not x. So your y will be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. But take note here, the a is 1, the coefficient of y squared. The b it's a negative 2, the coefficient of y. Then the c is equal to a negative 3, the constant. Substituting that, we'll get minus, then minus 2 plus or minus the square root of minus 2 squared minus 4a 1c minus 3 all over 2a 1. So it means your y is equal to, or your y is equal to, go to the calculator. So it will mean that we are going to have minus 2 plus the square root of b squared, which is minus 2 squared minus 4a, which is 1, c, which is a negative 3, all over 2a, which is 1. We are getting a positive 3, or we are going to put a negative there. We are getting a negative 1. So we are getting a positive 3 or a negative 1. But take note, the question wants you to solve for x and y. So once you get the x value, once you get the y value as we get here, we now want the x value. So you have to go and substitute. Remember, we had established that our x is equal to 3 minus y. So when y is equal to 3, we had established that our x is equal to 3 minus y. So when y is equal to 3, it means x is equal to 3 minus 3. X will be equal to 0. And when y is equal to minus 1, it means the x will be equal to 3 minus y. Y is minus 1. Simplifying that, x is equal to 4. So it means this is our y, then this one is our x. And it is very important to take note that it is very important here. Let's take note here. Let's create space here. Right. Or let's so using this equation does not necessarily mean that x must be made the subject of the formula. You can make y the subject of the formula. If you make y the subject of the formula, this is equation 1, this is equation 2. So to formulate equation 3, you can decide to make y the subject of the formula. It was going to be y equal to 3. Then you transpose the x here. Is the x that we are going to transpose. So it was going to be minus x. So it means this is now our equation 3. So we substitute this equation 3 in 2, meaning to say wherever there is y, we are going to put 3 minus x. So the equation becomes x squared plus 2y 3 minus x squared. being equal to 18. Simplifying this, it's gonna be x squared plus 2. Take note, you do not have to multiply this 2 in this bracket before simplifying this. So it means this part has to be simplified first before multiplying by 2. Don't put the 2 in brackets. So that one is going to give us 9 minus 6x plus x squared. This must be equal to 18. Then we are going to have x squared plus, simplify here. So it's going to be plus 18 minus 12x plus 2x squared equal to 18. Then these are like terms. Put them together. So it's gonna be 3x squared, then minus 12x equal to 18. Okay, let's take this one plus 18. Then we take this 18 which is there, transpose there to be minus 18 equal to 0. So we are left with the 3x squared minus 12x. This will give us 0 equal to 0. Here, we can divide it throughout by 3. So we'll be left with x squared minus 4x equal to 0. You can use the quadratic formula, but take note, if we are to use the quadratic formula, in this case, it means a is equal to 1, b is equal to minus 4, c is equal to the constant we do not have, so it means it's 0 there. But in this case, let's use the factorization. So by factorizing, x is a common factor, then we are left with x minus 4 equal to 0. Therefore, x is equal to 0, or x is equal, or x minus 4, or x minus 4 is equal to 0. So our x is equal to 0, or our x is equal to 4. Once you get the values of x, we now want the values of y. But take note, it's already established that y is equal to 3 minus x. So it will mean that here, it will mean that y, when x is equal to 0, so y will be equal to 3 minus 0, y is equal to 3. Then when x is equal to 4, it will mean y is equal to, here it's 3 minus 0, not here, it's minus, will be 4. It will be 3 minus 4, y will be equal to minus 1, which are the values that we got in the previous exercise. These are our solutions for x, and these are our solutions for y. Always make sure that you have to finish the equation because you are solving for both x and y. Don't make mistake of only solving for one. Then let's go to the last part. So here, let's remove this. Let's remove this. Let's answer question 1.3. We are on question 1.3. You are given that root 5 to the power x minus cube root of 2 to the power y is equal to 17. If you are to check, we can apply our laws of indices here. So it will mean that root will simplify root here using the law which says root x is equal to x to the power half, or we are saying the mth root of p is equal to p to the power 1 over m. Using these rules, we can simplify this, so it will mean that this can be written as 5 to the power half, then raised to the power x minus this one can be written as 2 to the power 1 over 3, then to the power y must be equal to 17. If we simplify this, we are now going to apply a rule which says a to the power b to the power c must be equal to a to the power bc. You have to multiply those exponents, so it will mean that this can now be written as 5 to the power half x, or 5 to the power x over 2, when you multiply this by this, minus 2 to the power y over 3 must be equal to, if we are to check this 17 here, if we are to go and check the 17 there, that 17 can be written in a format that involves here, that involves the difference between a perfect square, because here we are having a square root. So we want to link a perfect square and a perfect cube. Here we have a square root, here we have cube root. So it will mean that this 17, we can also write it in terms of a perfect square, which is 25, minus a perfect cube. A perfect cube here is gonna be 8. So if we are to check that, this can now be written as 5 squared minus this perfect cube is 2 cubed. In other words, the values that we are supposed to choose, what we said perfect square and perfect cube, they were supposed to be related to this 5 and this 2. So we wanted a perfect square that relates to 5. It was just an issue of manipulating 17 so that we end up having something that can correlate to what is there. So if we are seeing here, the bases are, here it's 5, and here the bases are 2. So from here, we can therefore conclude that our x over 2 is equal to 2 there. Therefore, our x is equal to 4 after cross multiplying. It means that 2 is the same as 2 over 1. So if we cross multiply x times 1, it's going to be x 2 times 2, 4. And the y there over 3, which is the exponent of 2. Y over 3 there is equal to 3 there. And take note, our y will be equal to, 9. How did we get the 9? Here we were having over 1. Then y times this is that. 3 times this is 9. Then it's saying determine the value for p, which is equal to x times y. So it therefore means that we can simply go and say here, therefore, sorry, hence, after getting that, hence, p, which is equal to x times y, will be equal to x is 4 times y, which is 9, which is just going to give us a 36 there. Alternatively, it was possible that we can use trial and error. Remember, trial and error is also a method that is acceptable in maths. So it was possible that you would use trial and error. Let me use the red. So in using trial and error, we were going to start from here. But you do not change the line. We do not change the. So it means we're going to end up having. Take note, we're not going to change anything on the right hand side. So we're going to end up having 5 to the power x over 2 minus 2 to the power y to the power y over 3 is equal to 17. But paying attention to what you are told here, you are told that where these are natural numbers. So, since these are natural numbers already, we can conclude that x must always be an even number. Must always be an even number. It must be a natural number. X must be an even number, because the moment we put any number which is not even number there, it's not gonna be a natural number. So using that, we can now use trial and error. Let us go and put 2 there. If we are to put 2 there, when x is equal to 2, when x is equal to 2, go and substitute there. It means we are going to get, if we substitute 2 over 2, we're going to get 5 to the power 1 equal to not equal to 5 to the power 1 minus 2 to the power y over 3 equal to, what are we going to get? 17. Then minus 2 to the power y over 3 equal to 17. Transpose this 5 to this other side. 17 minus 5 is 12. But if you check, we cannot express 12 with this base. So it means this one was not acceptable, because the answer that we're going to take for y won't be natural number. Let's check when our x is 4. We're going to just go and put 4 there. So if we put 4 there, it means here it was gonna be, let's just go. If when x is this one, we said not possible, y won't be natural. Go and substitute 4 there. So it means 5 to the power 4 over 2 was going to be 2 minus 2 to the power y over 3 is equal to 17. Here it's 25, so we're going to be left with minus 2 y over 3 there will be equal to 17 minus 25. Here you get minus 8. Divide both sides by a negative. 2 to the power y over 3 is equal to 8. 8 can be expressed as an exponent with base 2. So 2 to the power y over 3 is equal to 2 to the power 3. From there, we can now take note here. We highlighted when x equal to 4. So here we are left with y over 3 equal to 3. If we are to simplify further, it means this one is the same as 3 over 1. Let me write here correct well as y over 3. So when you cross multiply, y is equal to 9. So x is equal to 4, y is equal to 9. And as you can see, 4 and 9 are natural numbers. So we just come and substitute there. Therefore, p equal to x times y will be given by 4 times 9, which is equal to 36. Thank you. Thank you. Keep pushing, keep practicing.